Okay, let's get started. Good morning and afternoon. I can tell we've got some regulars here in the chat because we always love to find and see where everyone's tuning in from. So shout out to Max from Florida and Antonio from Lisbon and Gio from Scotland. If anyone else would like to let us know where they're tuning in from, we'd love to kind of see how many pockets of the world we've hit. So we've got a South Carolina and a Romania, Millbrook, Millbrook, New York. Thanks, Matt. We got Texas, another from Philly, South Carolina, Ken. What we'll do is probably wait for, another minute or two, just to allow a few stragglers to come in. It's got a really large amount of attendees here too. So, and at the end of the meeting, we're actually going to be sharing the link to register for the next one. So feel free to tell your friends and colleagues as we're getting more ahead of this. And oh, we've got another one from Belgium and India. Oh, someone from Hamilton, which is a stone throw for me. So nice to meet you, LG Group, Virginia. For those that have missed the last few minutes, definitely shout out where you're tuning in from. I think we're going to start in about 30 seconds here. We got another from Romania, another from India. Amazing. So we're definitely hitting a two continents here. So wanted to introduce myself. I'm one of the newest members of the team. My name's Brandon. I'll be hosting the next one next month with James and Varun here. So what we intend to do on the seminar for today is do about a 30-minute presentation. We're always trying to figure out new topics, so feel free to send us emails and suggest what to do for future seminars. But today's is for, thermal practices. Thermal requests we're noticing on RFPs from end users and clients and owners are becoming more and more requested. As drone equipment is becoming more economical, and then of course there's more robust offerings in the market here to function the captured data, making things a bit more precise and much more efficient from a workflow. So what to expect on this seminar is another 30-minute presentation or so, and then please feel free to write your questions down because we'll have the followed up after that with another 15 minutes or so of questions. And yeah, thank you for tuning in, and I'll pass this over to Varun.
Brilliant. Thanks, Brandon. So, hi all. So, thanks so much for taking the time today. So, as Brandon mentioned, what we're going to be covering in today's webinar is going to be about thermal drone surveys and try and share some of the tips and tricks and best practices with you so that you can sort of transform site capture and building assessments using drones and thermal data. So before we get into thermal, just a quick sort of about us. We won't dwell on this too much, but just so that you know who we are. So we are Hammer Missions. We're a software company founded in 2019. And essentially what we do is we're a software platform that assists with drone inspections, thermal drone inspections, but also just generally drone inspections of different structures. We've been fortunate enough to be sort of used on over 5,000 projects at this point. Roof projects, facade projects, building envelope projects, and have sort of been able to sort of support over 20,000 drone flights. I'm Varun Sarwal, so I'm the managing director here at Hammer Missions. My background has been in drones and AI for the last 10 years. Very pleased to be joined by Brandon Kitchen. Brandon's joined us on the other side of the pond. So I'm based in London, and Brandon's in Canada. And so if there's any sort of people here from Canada wanted to reach out to a local, Brandon's your sort of point of contact. I think with that, kind of once you go into thermal drone data, let's get into it. So before we sort of go into workflows and tips and tricks, I want to sort of try and motivate why thermal drone data, why capture the data in the first place. Essentially, it boils down to four main reasons. I think when we're speaking to clients and we're speaking to sort of different stakeholders, it's quite important to always motivate why use thermal data with drones. First and foremost, I think goes without saying, drones are very efficient ways to capture data when you're capturing data across roofs or solar panels. I think if you've got large areas that you need to walk, being able to fly those areas is just a lot more efficient. But also drones provide a lot better access when it comes to both roofs and facades. Sometimes you've got pitched roofs that you can't really get on top of. Other times you've got sort of really expensive side instrumentation methods like scaffolds and string stages that aren't kind of viable. And so better access is another big area of focus for drones. And thirdly, you've also got this sort of trend going on at the moment in the industry where the camera technology, infrared technology, has become more and more accessible. I remember when I started with drones, I think 10 years ago, the infrared camera, the thermal camera used to cost 3 times the cost of the drone itself. And everyone used to be really worried about flying a thermal camera just because of the cost of the camera on there. And it used to be a separate system. But now you've got consolidated systems and they've become more accessible than ever before. And that also really sort of promotes the usage and the actual utilization of the technology. And the final thing here is essentially the application. Ultimately, everything is driven by the application. If there isn't a use case where you can use the data, then you can't sort of justify any of the cost. And so applications in moisture surveys and heat loss assessments have been the driving force for sort of thermal drone data. Just kind of going into thermal imaging 101. So I'm sure the audience today is a bit of a mixed bag. There might be people here who are just starting out with thermal data, and there might be sort of thermal data pros. And we want to sort of like try and focus this presentation so that it sort of has something for everyone. So in terms of thermal imaging, how does it work? Well, you've got thermal cameras that are able to detect infrared energy emitted by objects, and they sort of create this visual representation of radiated temperatures. It's not sort of quite true temperatures, but it's more sort of the radiance of that temperatures. And essentially what you get is a heat map. So you're able to sort of understand how the sort of radiated temperatures are different between different materials. And so this relies on its emissivity, which is essentially a property that materials have to radiate thermal energy. And because different surfaces, different materials emit this sort of at different rates, that just allows us to create this sort of heat map so that we can tell what areas are colder than other areas, what areas are hotter than other areas. And that can then be used to sort of use for investigations around moisture-related issues or heat loss related issues. So that's sort of thermal 101. But having understood sort of thermal 101, and we understand why we want to use drone data or drones for capturing this data, what are some of the deliverables that we can now expect? I think the 4 main deliverables that we're seeing in the industry at the moment, I think we started off probably 5 years ago with a lot of orthomosaics. So a lot of the industry was driven by orthomosaics, which is still the case today, which is essentially just for a stitched image of your roof or facade or a PV plant, essentially stitched image put together of all these different thermal images. And it's called an orthomosaic, which is a bit of a kind of a mouthful, but it's a word that sort of indicating that these images have been scale corrected. So they're actually usable for measurements and they have the right sort of scale. And that's done through a process called photogrammetry that I'll touch on upon a little bit in the later sections. But also now that you have sort of good thermal cameras, you can actually create 3D models. So it's not just about 2D deliverables, but you can also produce 3D deliverables with thermal drone data, which just allows you to be able to depict the sites in much more detail and capture a lot more contextual information. The third deliverable is to sort of be able to compare thermal and visual data. And I'll show some examples of this today to kind of give you a sense for how can you compare and contrast the thermal data with visual data, because thermal data is not always the full picture. You need to be able to have the context into understanding why a certain anomaly is happening, why a certain area doesn't look quite right. And the final is PDF and Word reports, which is obviously recommendations once you've sort of had the findings, what to do next. Because as we all know, I think the data is only useful once someone is able to act on that data. So I think from an industry perspective, what's really important for all of us to do is to think about how can we make the data more actionable for the stakeholders that the data is being delivered to. So with that, what I want to do is I want to go through a typical workflow with you today in terms of what thermal drone data looks like and how it can be captured, processed, and analyzed. So I'm going to minimize the screen here and go into go into ham emissions. So I'm going to use ham emissions to give you a sense for kind of how to create thermal outputs. So let's kind of go into the data analysis side of things. So we're in the data analysis side of things at the moment. And what I've got on the screen is essentially, let me just go back to projects. I've created two different projects in ham emissions. So in the software, what I've done is I've taken photographs, thermal photographs and visual photographs of a roof, and I've created two different projects. And I want to try and explain how to kind of use the data. Once we understand how the data is used, I will also then work my way backwards into what might be some of the good ways to capture the data. So let's go into the thermal data first. So essentially, what you see on the screen is a 2D orthomosaic that's been overlaid. Well, at the moment, you see a 3D model on the screen. Let me just go back to my 2D view. So what you see on the screen is a 2D orthomosaic that's been overlaid on Google Maps. And this orthomosaic has been created by essentially stitching together 314 images. All of those images can be seen over here in the bottom of the screen. So all of these images were essentially stitched together to produce the 2D orthomosaic. Not only that, they were also essentially processed together into a 3D model. And so if I go back to our 3D, you can sort of see the roof and the facades of this particular property that were stitched together into one sort of 3D deliverable. And the way this is done is that you essentially fly the drone across the roof and the facade in a very structured manner, and essentially take these overlapping photographs in thermal to be able to produce this result. So I've just sort of opened up the image map, sort of showing where the photographs were taken. So each one of these yellow dots that you see on the screen, each one of those is essentially a photograph that the drone took under an automated flight path. So when we are looking at the actual 3D model, that's an automated processed result that's created from all of these images. And these images or these thumbnails are the same sort of images that you see in the bottom of the screen. And the goal here is that you want to create one stitched image from all of these 2D sort of images. And the reason to do that is to essentially provide context. So you want to be able to look at the entire roof and the entire facade in one go. And so you can essentially do that by uploading all the data and then essentially creating the 2D or 3D output. And just to kind of explain for people who might be new to this, the way you sort of do this is by taking these overlapping images. So in my 2D view over here, if I click on this photograph here, so this particular dot, it brings up the photo that was taken, and we can kind of tell from the actual photograph. So for example, we follow this, let's say, pitched structure on the roof. The same structure will also appear in the next photograph, and it would also appear in the previous photograph. So there is this sort of shared region between all these photographs, and all that shared region is actually being used to create the 2D and 3D outputs. Now, with thermal data, it's really important to get this overlap right. And I have a whole section on overlap in GSD that I want to talk about later. But the reason why everyone keeps, talking about overlap over and over again for thermal data is because thermal data tends to be really low resolution. So if you compare thermal data with visual data, you will notice that the actual resolution of the images is really low for thermal data. And so let me do that. Let me compare the thermal imagery with the visual imagery. So I'm going to put both thermal and visual side by side. So I've got thermal data on the left-hand side, and I've got visual data on the right-hand side. And what I'm doing here is I'm loading two different models side by side. I can also go to the 2D view so that we can look at the roofs. And so what we will notice is that if we look at any particular area on the roof, the thermal data, the images actually have less resolution compared to the visual. And that's one of the reasons why you need to get really high overlap between images for thermal data. Because if you don't have high overlap, essentially the stitching of the thermal data becomes a lot harder because there aren't enough features that the software can use to say, okay, this part goes with this part, that part goes with that part. To maximize the opportunities for the software to create this result, you need to have high overlap. So once you've got the 2D output over here. So you've got the 2D output on the left-hand side for thermal, visual on the right-hand side. What does the workflow look like thereon? Well, first of all, you can already see the different patterns that different materials exhibit on the thermal data. So you can sort of see it's always a very colorful exercise working with thermal data. So all the sort of colder regions are darker in color, and all the hotter regions are brighter in color. And so basically, you're able to identify these colder regions and cold patches, and you're also able to identify the hotter regions and the hot spots. And so what I'm going to do is I'm going to look at, let's say I want to investigate that specific cold patch over there. So that cold, dark region that's there. If I want to investigate that, I can just click on that. And then essentially what happens is Hammer Missions will bring up the closest photograph showing me that particular region in more detail. And this is actually the thermal photograph that was taken by the drone. And it would also show me the visual photograph taken by the drone on the right-hand side. And that cold patch that I clicked on is visible right here. And so what I'm able to then do is I can actually scale and tune the temperatures. So essentially I can look at the contrasting radiated temperature between different regions of the image to really bring out that sort of that anomaly, and then sort of understand if there are other anomalies that might be hiding, because sometimes based on what was captured in the scene, that anomaly may not be immediately visible. So you're able to actually go in there and you're able to scale and tune this data. In fact, you might be better off sometimes showing the anomaly in completely different color palettes. So what you're able to do is that you can actually go in and change the color palettes. And let's say if I went to jet or rainbow, you've got, for example, now it's sort of really highlighting some of that sort of hotter area there and a cold patch that's forming over there with respect to kind of the darker region. I can go in there and I can actually kind of give it a tag. So if I want to sort of give it a tag in terms of sort of cold patch, I can just give it a tag, and then that gets stored on the platform there. And then also I can give it a tag on the right-hand side over here on the visual image as well. And so those sort of tags are then stored on the software, and then you can essentially carry on conducting the assessments. The other thing is also when you create a specific scaling and tuning attached to an image or a particular sort of anomaly, all the other images in that specific region will now start using the same scaling and tuning. So for example, I had to tune the images to show me in this color palette, and now it's going to actually use the same tuning across that sort of localized region so that any image I click on in that region will have the same tuning. And so that's kind of like one way for you to be able to kind of apply a localized tuning. And then if you wanted to sort of not just look at these cold patches, but let's say there was a hot spot forming somewhere. So if you go to some other part of the property, let's say I'm looking at this particular part of the property now. I've got, let's say, this hot spot and I want to investigate that more. I can just double click on that, and then it's going to show me this particular area. So now I'm looking at maybe there's these vents over here in the property, and maybe there's not an actual anomaly here, but it's a sort of brighter region. So there is sort of some heat signatures that is being registered over here. Once again, for a hotspot, I can just go in and I can create my annotations, and that can allow me to sort of store all that information as I'm doing the inspection, sort of in the images as I'm walking through the roof. And so this just makes it super simple and super easy for you to be able to actually go through the entire roof and look at different areas of concern or wherever you might see different anomalies. And it gives you the ability to go from the zoomed out level, seeing the whole thing, to go to the granular level to see the localized thing, find the anomaly, and then understand what it might be or what might be causing it, because you've also got the visual representation on the right-hand side. And you can do the same process in 3D. So if you are looking at the property, you can look at the property, let's say, from a facade perspective. If there are specific anomalies that were jumping out, you can actually double click on those anomalies, any sort of bright spots or sort of cold patches that are jumping out. You can just double click on that and then bring up the closest image. that shows you that part of the building. So, for example, over here, I'm looking at the specific area if I wanted to probe that more. And I can also sort of double click on the visual image to get a better sense of that visual as well. And with visual, the nice thing is you can always zoom in. So I can zoom in to sort of see what's actually on the roof, and there's any electrical equipment here that might be causing the bright spots. It's quite easy to be able to sort of discern that, because one of the things with thermal data assessment is that there is a lot of things going on site, and not everything is an anomaly and not everything is a deficiency. You might have anomalies because of just very sort of expected things like electrical equipment and other things on the roof. So just kind of knowing what you're looking for and knowing what's actually on the roof with the visual data is really helpful. And so you can actually go in and cross-check why you're seeing those anomalies and what's there in the visual data in the side-by-side mode. So that's what you're able to do. And then that's kind of how you can do the assessment. But hopefully you can already see the sort of the power of drone data with respect to kind of being able to capture all this data, put together the visual and thermal 3D models, and then use that to be able to do the inspection and then to do the analysis of where some of the anomalies might be. Once you've done all of that, you can also then export the data into a PDF report. So what I've got over here is essentially a PDF report that has been generated. It's just all automatically generated from the software. So when you're doing the inspection, you're kind of automatically building the report in the background. You can add a cover image showing the author mosaic that has been captured. And you can also show, essentially, you can add the executive summary talking about all the different observations on this particular project and what the report will essentially go through. And so essentially goes through the survey, when the location, the time, date, when this particular survey was conducted. And then it shows you sort of like all the different annotations and all the different hotspots and cold patches. And you can click on any one of those, and then it sort of goes into what the specific anomaly looks like, where it is in the drone photo, and essentially the report cycles through all the different anomalies that have been picked up on the roof. And you can also create a visual report to complement the thermal reports. That's always a sort of a recommended thing, just because that allows anyone reading the report to understand what might be the sort of actual reason or causes behind the anomalies that have been picked up. So that's just sort of a very quick sort of overview in terms of the typical data analysis workflow. What I also want to do is give you a sense for how to go and capture all this data. So if we sort of look at sort of the flight planning side of things, so I'm going to go into our flight planning side of things. So now I'm in Hammer Missions, but I'm now looking at the mission planning. So over here, what we're trying to do is we're looking at the same building as before, but the goal here is to essentially create a flight plan that allows us to fly the property and get the right images in the right places, which is half the battle, just to be able to get the right data. If you don't have the right data, then all of the post-processing workflow that I just showed, that's kind of non-relevant, because you have to kind of start with good data. So what you got on the screen is basically a flight plan that's been created. And the way this was created is that you just create a boundary or a polygon around the structure you want to capture. So let's say I'm interested in this roof. I draw a polygon around the roof, and I can essentially create a lot of these different flight plans for the roof and facade inside sort of a folder structure, because typically you'd want to have different flight plans for roofs and facades. And so let's say if I'm flight planning, I would want to, in an ideal world, I would create an infrared or a thermal flight plan for the roof, and also both a flight plan for thermal and a flight plan for visual, because that allows you to optimize the resolution for each. I will talk about later in the presentation about different drone cameras, and sometimes you have both cameras, and should you capture data for both at the same time. But essentially, you're able to go in there and you're able to actually set up the camera you're looking to capture the data with. You can set up the altitude of flight. You can set up the building height. You can set up front and side overlap. So as I mentioned, overlap is the shared region between images from the data analysis workflow. This is where you set up all of those different parameters to ensure that you're getting high quality data. You can set up the gimbal angle. So you're looking essentially straight down on the roof, looking straight kind of in an orthogonal manner. And essentially what we're doing here is we're setting up all the different parameters for the flights so that you're able to create a flight plan and you're able to understand how the drone will fly and how it was going to take all those photos across the roof. And you can visualize before you go to site what you're looking to capture, what the flight plan will look like, how many photographs you will take, how many batteries you might need, and what the expected flight time will be. So this just really allows you to plan your flights before you go to the sites. And it allows you to essentially plan the data capture so that you get structured data out of it. I think for people who are kind of outside the drone industry, a lot of people think that our drones are automated and, it's great to have autonomous drones and autonomy is great. And actually, people inside the industry realize that the reason why we automate drones is not because of autonomy. We automate drones because we want to get high quality data. And that's sort of like that should be the guiding principle behind using automation, because what you want to do is you want to minimize any variables that prevent you from getting high quality data, because all this data needs to have the right structure so that you can process all of that data and then create the outputs and deliverables that you want to create. So that's sort of a little bit about the flight planning side of things. Once you've done the flight planning, you can sync the flight plan with the Android application. So at Hammer Missions, we have a software application that integrates directly with the drone's remote controller. And then that's what allows you to actually on site fly the drone and capture the data. So I'm going to move into a video where this particular property was captured by Dan as the pilot on this particular mission. This was captured with a Mavic 3 thermal. So essentially, once you have the flight plans, you can go into the app. This is a sped up video, but the drone would automatically capture both the facades and the roofs. And it would also give you a 3D view to telling you where the drone can fly and how it's going to take images. This is the roof capture where you're capturing the thermal data. But once again, the automation is very much to be able to produce high quality results as opposed to automation for automation's sake. So with that, hopefully everyone's had a chance to kind of build a high level understanding of what is the typical workflow and how we go from data capture to the data analysis. I also want to spend some time talking a little bit about the different sort of best practices that we want to keep in mind. So yeah, moving on. So yeah, I think I came across this particular meme recently, and I feel like this meme could not be more true when it comes to sort of drone data. I think it's very hard to kind of get this facts without having kind of been out there and capturing data, but almost every single time the drone data, the actual data input matters more than the sort of like the modeling that you're using in the post. Of course, there are different tools and tools can make life a lot easier. But if you don't have the right data, then basically, that prerequisite is not fulfilled. And, the kind of the job is somewhat of a unsuccessful job if you don't have the right data. So data matters a lot more. And it's true for like 2D maps, it's true for 3D models, it's true for any AI models as well. So data is sort of king, and that's sort of really important to bear in mind. And having said that, what are the best practices for data capture? And I have there's a big laundry list of best practices, but I wanted to sort of distill it to like, let's say the top 8 things that maybe are good to sort of pay attention to, especially when you're starting to capture thermal data. So first of all, it's got to do with time of day. So when you want to capture accurate thermal data, especially when you're capturing data of things like roofs and facades and buildings, one of the things you want to do is you want to capture at a time of the day when you're maximizing the thermal contrast. So thermal is all about sort of using the delta between different surfaces and different materials. So if you're capturing at a time of the day when the contrast is not high, then you're basically sort of getting in your own way by not giving thermal the right opportunity. So capturing the best time to capture generally is early morning before sunrise. And in some conditions, you can also use late evening, but early morning tends to be kind of one of the best conditions. And it's this time where you have structures that are kind of showing their temperature differences more innately. And you also have reduced effect from the sun, which can sometimes, create noise in the thermal data and essentially doesn't give you the accuracy you might need. The second thing is to essentially avoid any kind of adverse weather conditions. So I think the mantra for a lot of thermal drone data capture needs to be no sun, no rain, no kind of snow, because all of these different things, they interfere with the innate temperature and the temperature differences that we're trying to pick up on. So you need to sort of avoid the, rain, precipitation, snow, as they're just going to create more and more inaccurate results. So that's another important aspect to consider. Essentially, the time of the day and the day of the flight are really important things to get right. The third thing is the choice of drone. Now, this gets a bit, I think there are sort of pros and cons and, the best drones to use for the capture. I think that we're now in a world where DJI has produced sort of dual camera systems. So you've got essentially the DJI Mavic 3 Thermal. Predecessor was Mavic 2 Enterprise Advanced, and now the Matrice Sport Thermal. And so all of these drones have multiple sensors on board, including a wide camera, wide visual camera, zoom camera, and then also the thermal camera. And so the first points I would sort of say is that no matter which drone you use, the important thing here is to optimize the data capture. So ideally, if you want to maximize resolution for thermal data and maximize resolution for visual data, what you should be doing is to capture the data separately. Now, this doesn't mean that every job you're capturing the data separately. We know that the whole principle of having both cameras at the same time, it's great to kind of be able to capture both the thermal and visual image at the same time. But the thing to realize is that the GSD for visual and thermal and the resolution are completely different. So when we're doing our flight planning, if I go back to our flight planning, which is over here, essentially, to get the best results, it's better to have this one flight, so one flight for your thermal, and then have a different flight for your visual. And the reason I say that is that if you look at the same sort of flight that is configured to the Mavic 3 thermal wide camera, you're able to get a certain GSD, which is 0.7 centimeters per pixel at 100 feet. It's because of the resolution of the camera and the camera specs. So we're looking at 0.7 centimeters at 100 feet. And if we go into IR for the same roof, the IR camera will capture, we go to at 120 feet is 2.93 centimeters per pixel. So the GSD, or the resolution you're getting on the roof, is completely different. And so if you want to optimize best resolution for both, it's actually better to fly them independently so that you have a flight plan for each one of those, and then you can essentially capture the data that way. The second thing is dedicated versus dual cameras. This is also a sort of a trade-off area. So you could use dedicated cameras that are, let's say, you can have a great thermal camera and then a drone to carry that thermal camera, and a great visual camera and a drone to carry that. But essentially, you're getting now into the territory of having essentially a bigger drone that could carry a thermal and a visual payload. And for some of the building surveys, maybe you don't have the logistical space or clearance to be able to have a big drones. So again, deciding between dedicated and dual cameras is a big sort of area that probably is worth thinking about. A lot of the times we're seeing dual cameras now being utilized, and the efficiency of having one drone to be able to capture both the thermal and visual. And the last but not the least, the most important thing here is the resolution and sensor quality. So at the moment, having a visual sensor, a thermal sensor, sorry, of 640 by 512 resolution or higher is pretty good. I mean, that's kind of what we're seeing for most of the thermal surveys. That resolution will keep going up over time, and that's going to improve the 3D models. It's going to improve pretty much everything. But so far, that sort of is becoming the kind of standard that we're seeing for most thermal data capture. So just ensuring that you have at least a thermal camera that has that resolution is really important. Anything lower than that can sometimes be a bit tricky from the perspective of being able to create stitched outputs, but also just from the perspective of being able to see what you want to see. So that's that. I'm going to come into ground sampling distance, which is also quite an important area of concern. So if you're already capturing drone data, I'm sure you're familiar with this, but just sort of a quick sort of 101 on ground sampling distance. Basically, when we fly drones, we're flying data to capture data to a certain resolution, to a certain spec. And so the distance between every 2 pixels, the physical distance on the surface, let's say you're mapping a roof, the distance between the every 2 pixels, this is on the roof in terms of the kind of how it's represented in terms of the drone's camera. The distance between every 2 pixels is essentially the ground sampling distance. So you're sort of sampling, the sensor is sampling the ground, and you're trying to figure out what is the sort of smallest distance that the drone can see. So for example, if you have this drone in the image, at a certain height, its camera, for example, might see 1 centimeter per pixel. And if we make that height lower, maybe it's 0.5 centimeters per pixel or 0.25 centimeters per pixel. And if the height is really high, maybe it might be all the way up to, 10 centimeters per pixel. And so basically your sampling or your resolution of the data is a function of how close or far you are to the roof. You can think of it like resolution, screen resolution in some sense, which is, what is the quality of the data you can expect? And I think this is quite important for thermal. And I say that because with thermal data, one of the challenges is that we're working with a low resolution camera, and we're also working with a camera that fails to achieve a really low GSD, i.e. high resolution. And so what you need to bear in mind is what is the actual anomaly you're looking for? And if the anomaly that you're looking for, if your GSD is not smaller than the anomaly, i.e. that whatever you're looking for will just be so small that your resolution wouldn't show it, then you essentially won't be able to use the thermal data for your assessment. So this is where it really pays to understand what you're looking for. So for example, if you're looking for moisture related things, whether it's on the roof or it's on facades, a lot of the moisture tends to be kind of big in footprint. So it's sort of taking up 10 centimeters or 20 centimeters on the roof of the facade. And so you can get away with a 2 to 5 centimeter GSD in terms of what resolution you're capturing the data. But let's say if you're capturing something like air leaks or really small sort of energy openings or solar cell hotspots, these are between 1 and 5 centimeters. And so at 2 to 5 centimeter GSD, you may not be able to see them because your resolution is actually, your smallest resolution is bigger than the thing that you want to actually see in the data. So actually having an understanding for what are we trying to detect over here, and using the institutional knowledge of the building or working with different stakeholders and understanding what is it that we're trying to achieve, and then back calculating what GSD do we need, and therefore what camera do we need and what altitude do we need to fly at, is sort of like the right way to look at things, where you're starting from the end application and you're working your way back. Unfortunately, a lot of the times what happens is that people become really sort of fascinated by the tools they have and then they start with the tool and then kind of work their way from that. And sometimes that's not the most ideal way of doing it, because you should almost always start from the end result and work backwards. So that's a little bit on GSD. I think I've talked about overlap already when we were talking about the typical workflow. So you have this idea that you want to take 2 images that are overlapping with each other. And that's essentially because you want to ensure that there are enough features that photogrammetry can use the process to essentially stitch all this data together and produce a 2D map or a 3D model. And so recommended overlap tends to be 80% for thermal drone data. For side lap, you could go to 70%. There's always a trade-off with everything you do in drones. So if you go too high on the overlap, sometimes what you will find is that you're taking too many images and the flight time has gone up by a lot. And so what you really want to do is you want to sort of find a balance between high overlap, but also good flight time and minimal number of images. And so that's really important. So to give you a sense for this, if I go back to our flight planning example, so I've got at the moment front lap at 75, side at 80. And so that's giving me 446 photos. But let's say I went front lap at also 80 and I read this flight plan. Basically, I'm going to have, and I went to, let's say, 70% overlap here, and I went to 70% there. Now I've significantly reduced my photos from 449 to 254. And so that's great. But let's say if I was at 90% front overlap and 90% side overlap, which sort of go here. Now I'm looking at 1,000 photos and, or 2,000 photos. And so that at that point is just too many photos, and it's sort of more flight time than maybe we need and more photographs than what we need. So essentially there's a balance there. And at 80%, we're looking fine. And maybe that's fine for this particular structure. What we kind of have to understand is that if you have a really large roof, maybe those values need to come down, and you have a good balance between overlap and the area that you're looking to capture. So overlap's really critical for thermal drone surveys. Always worth kind of double checking what overlap you'll be getting. And also the important thing is that if you're doing a roof survey, you also need to account for the height of the building, because when you have the roof survey, one of the challenges is that the overlap on the roof is different to the overlap on the ground. And so your software needs to be able to handle that. And so the building height really matters when you're sort of calculating all these parameters. So yeah, that's a little bit about overlap. And if we go into some of the other things, so looking at the thermal camera settings. So when you're actually capturing data on site, in the field, one of the things you want to be mindful of is that you want to try and maximize the thermal contrast, or you want to maximize the actual sort of difference or delta between different materials. So over here in this image, you can see you've got some areas that are red, you've got areas that are blue, and you've got areas that are somewhere in between. What you don't want is an image that just looks very similar. So something like, a completely red image or a completely blue image with no contrast whatsoever. Because if you've got a very washed out image where everything looks very uniform, what's going to happen is that you might be able to use the imagery, but if you want to stitch all that data together into a 2D map or a 3D model, it's going to struggle to get stitched together because there are no contrasting features for photogrammetry to use to produce a 2D map or a 3D model. So really important is to make sure that you've got sort of variation in your actual thermal thermal camera settings. And that variation or contrast, you can actually do that by going into the remote controller and setting up how the thermal camera is set up and the sort of range in which it's operating to be able to maximize the contrast between different objects in the scene or different sort of areas that are being scanned. Sometimes if you really are in an environment where there isn't any contrast, maybe increasing altitude is another aspect you can try, because you're getting more things in the scene. And so every image you can actually have more contrast. But obviously, if you're raising altitude, you're now actually going into the issue of having not enough GSD. So there's always these different parameters that are fighting with each other. So you have to kind of make the best decision and use your judgment to sort of understand what is the right way to maximize contrast, but also not be compromising on GSD based on what you're looking for. Some of the final points here are around color palettes. So everyone's probably got their favorite color palette. I mean, it sort of gets people excited, we're all sort of getting all this colorful data. But when it comes to color palettes, we find that actually the iron bow palette, or the iron red palette, as it's called some places, tends to be the best color palette. So this is the palette that you see in the middle of the pack over here. So it provides really good contrast, and it allows you to highlight the subtle thermal changes. And it also allows you to sort of pick up on all these moisture and insulation related issues. If we go to the other ends of the spectrum, you've got rainbow, which is visually pretty appealing. So you can actually get very striking results from rainbow. So basically that's good, but it can sometimes over accentuate and it can sometimes overemphasize the minor shifts or deltas. And then you've got white hot, which is also good for a general overview, but it can be almost sort of too dull sometimes to be able to actually pick up on the anomalies. So we think that the iron bow, the iron red, creates the right balance between the two and is also more conducive to photogrammetry based stitching. And I think some of the final points here are around keeping the drone camera as orthogonal as possible. So whilst it's all very impressive to build a 3D model, I think what I showed earlier was this 3D model of the roof and the facade. Sometimes to do that, you have to use an oblique angle. And it's okay if the goal isn't to be super precise with the roof and the facade, but generally speaking, you'd want to capture the roof and facade separately and model the roofs and facades separately, because that allows you to be that much more accurate in terms of the thermal differences that are picked up, and you don't have additional noise in the data. That's another thing to keep in mind. And then finally here, I want to sort of just leave you with the data analysis flow. A lot of it is on the data capture. As you can probably tell, I went through 8 slides on the data capture and all the things that need to be borne in mind. But the data analysis, yeah, first of all, be or work with a certified thermographer. Really important to have someone experienced in the loop when it comes to analyzing thermal data, because there are many things. It's a science where you kind of need to understand lots of different things about thermal data. So always work with a thermographer on the team. Rest of it, yeah, process the thermal data, ensure you have a visual and thermal copy you can actually analyze, scale and tune your temperatures to ensure that you've got good sort of understanding of all the different anomalies. And then finally, you can annotate all the deficiencies and produce PDF reports. But yeah, with that, I would like to conclude. So thanks so much for listening. Hopefully this was helpful in getting a introduction, and maybe for the people who are a bit more advanced to get, a good recap in terms of all the different things to look at and think about for thermal drone data. I'm going to stop there. And yeah, if you have any questions, happy to take them now. But equally, there are some links on the screen. So if you wanted to schedule a one-to-one conversation with us with respect to the sort of workflows and how we can assist, we've got some links up on the screen and also an email address. But yeah, we'll stop there, and happy to take any questions. Great. I think there's a Q&A section. So let me just pull that up. So going to go to the questions sequentially here. So the open questions, Juan's got a question on what's the overlapping needed for thermal orthomosaic. We would suggest that essentially you have 80% overlap as a sort of kind of a base level. If you want to go below, don't go below 70%. If you're going to go high, don't go over 90. So that's sort of like the best way to think about it. Thanks so much. Jake says, thanks for hosting this. How does Hammer compare to Drone Deploy? I primarily offer thermal, but I've never experimented with 3D models for thermal assessment. Okay, great. So we like and respect Drone Deploy, great software platform. I think that the way Hammer's different is that it tends to focus a little bit more on kind of being able to do those scaling, and at least on the thermal side, being able to do those scaling and tuning workflows, being able to actually go to the images and modify those images, and then being able to actually map the compare and contrast between visual and thermal and producing reports. I think we're a bit more focused on roofs, facades, and building assessments. And Drone Deploy is a great platform, very focused on the active construction side of things. And so, yeah, that leads to subtle differences. But yeah, thanks for the question. Are there any regions or states that require certification in thermal image analysis? Yeah, so thermal, as I mentioned before, thermal image analysis for sure requires you to work with a thermographer. And so being a certified level 1, level 2 thermographer is quite a prerequisite for analyzing all the data. So quite important that you're working with a certified thermographer. So JP Sandwell's got a question. Do you side load Hammer Flights app for DJI controller that is for Mavic for the Matrice 30T? Yeah, so I mean, I guess side loading is one of those questions. It's hard to kind of what you have to do is basically you get an APK file from our website. So you can just download the app from hammermissions.com/app. And then you're able to, once you've downloaded the app, you can just install it, because the DJI controller runs Android. So any Android application can just be downloaded and installed on the DJI controller. So hopefully that helps with that. Another question: how do you ensure scale for measurement accuracy? How are you establishing the control? So measurement accuracy. So this is I think accuracy in drone data is a whole sort of subject, and I've covered a video on this. So what you're able to do with drone data over here is you're able to typically establish relative accuracy as opposed to absolute accuracy. So you're able to sort of understand every 2 points on that sort of 2D map or 3D model, how on a relative basis, what is the sort of accuracy there? A lot of it is based on kind of GSD, which is how close or far you are from the subject. For most roofs and facade surveys, because you're getting GSDs between 3 to 5 in terms of the actual pixels in the roof, your accuracy will be somewhere between 2 to 3 times that. So we're looking at any between 5 to 10 centimeters in terms of accuracy for thermal data. Visual data, your accuracy can be a lot higher because you're getting a lot closer to the structure. But those are the sort of accuracy benchmarks we typically see. JB Sandal's got another question. Why not fly IR mission specs and capture RGB concurrently if available? It would be oversampling RGB, but still be more efficient. Yes, so I think that's a good point. And I think this is one of those areas where it's a bit of it depends on what the job is. But if you want to fly both IR and thermal at the same time, you can absolutely do that. Because as long as your kind of main mission is on the IR, and then the RGB is the one that is sort of supplemental photos. So if you really want to optimize for one, then optimizing for thermal is a good idea. But the reason why I suggest flying them separately is because if you have your flight plans, flying them one after the other is just one after the other, and you can really then optimize for each camera. And you might find that actually the visual camera is a lot faster to fly, but you're able to get kind of much more detail. So if you wanted to get more detail on your visual, you can actually kind of have a different flight plan for that. Chief Geek, aka Mark Taylor. Okay. Thanks. I also do my thermal overlaps at 8080. Will Hammer support this? Yes, we do support 8080. So absolutely, that's very, very well supported. Got Paul. So no need for certifications for thermal analysis. No, I mean, as in like we do suggest the certifications. So as I mentioned, maybe this probably came through towards the end of my presentation. Always working with a certified thermographer is the right way to look at it. We've got Mohammed. Is there any specific temperature for thermal? I'm not quite sure the kind of gist or the motivation behind that question, but if you're asking, do we get temperature readings from thermal? Yes, you do have temperature readings, but it's important to understand that in the analysis or the workflow that we're showcasing, it's the difference between temperatures that matters a lot. You can go to those photographs, and when you move your mouse over them, you'll see a temperature reading, but it's just important to understand that's not necessarily the true temperature. That's sort of like what's been picked up by the sensor through the radiated temperature. And it's just the delta or the difference between them that we're most interested in the thermal analysis, even though there is a sort of temperature that you get from the actual raw images. So how do you plan a facade mission? We've got Chief Geek, Mark Taylor. How do you plan a facade mission on site to avoid heavy vegetation? So, good question. So facades and vegetation, I think trees are the biggest enemy when it comes to facade missions. I think there are a couple of different strategies for this. What we suggest for this is that, first of all, if you really have a very complex site, and you can't get down to the lower floors for the facade mission because of vegetation and trees and whatnot, one option is to use a gimbal angle. obviously, if you're using a gimbal angle, you are sacrificing some accuracy on the thermal side. So that's something to bear in mind. But the gimbal angle allows you to actually capture whilst staying at higher altitudes. And the other option is to actually try and capture the data more manually around the vegetation. So this would be around sort of flying manually, or sometimes you even seen for the lower floors, you're basically walking the lower floors with the drone to be able to get that data. So every site's different, and sometimes you have to kind of be creative to capture that. And we fully understand that you have to sort of take manual control for those sometimes. Michael's got a question on when will Autel drones be added to the fleet for planning missions? Yes, so Michael, we have looked at sort of flight planning for Autel. Unfortunately, I think the challenge has remained that that DJI's ecosystem tends to be a bit more open to be able to do flight planning in the way that we want to be able to provide the quality we want. So for the moment, there aren't any sort of future plans to support Autel for the flight planning, purely because of the fact that it's been difficult to be able to get hold of all the tools that we require to be able to integrate in a safe and compliant manner with Autel. Last conversation with them was last year, so we'll definitely touch base with them again this year to understand if that's changed. And we'll update our website if the support is coming soon. Antonio's got a question: can we put different distances from the facades and roof because different plans of objects? Yes, you can put different distances on the facades and roof because of different plans of the objects. If you're getting basically a certain GSD on the roof, that's got to do with the fact that that's got to do with the distance you're maintaining from the roof. So if you're doing roof survey at a certain GSD or distance, and you're doing facade survey at a different distance or GSD, that's possible. You just have to process all that data separately. So you'll create a roof model as a separate project, and then you'll create a facade model as a separate project, and you will analyze them separately. Because when you have very different levels of GSD on the roof and facade, it depends on how big the difference is. But if it's very different, then processing all that data into one 3D model can be hard. So brilliant. Is there any specific temperature for thermal? I think we've gone through that already. Huan's got a question. Not all the materials located on the roof are good for thermal inspection. I know that having small rocks over a roof makes it impossible. Other materials that are no for the thermal inspection. So I suppose the question here is to sort of say, can all roofs qualify for thermal inspection because of different material types? So I think that's a good point. There are, this is not just true for thermal, but also visual. Sometimes you have different types of materials. If you have a very reflexive material or material with very different emissivity, and you aren't able to actually discern the temperature differences clearly, or you have structures on the roof that are getting on the way, that would definitely make life harder for thermal. So any institutional knowledge you can use on the materials in the building should definitely be used to discern whether a thermal survey makes sense. So the general point holds that you need to understand the materials and the composition of the roof. Do you suggest any other drones besides the DJI 3T? Yeah, so in terms of the modern DJI drones or thermal drones, the Mavic 3 thermal, the Matrice 4 thermal, the Matrice 30 thermal are all very capable drones. And even on the Autel side, you've got the sort of 40, I think the Evo Max, all those sort of drones are also very capable and drones with respect to sort of the sensor. So yeah, there's a plethora of options, and almost all drones that are doing well in this category are the ones that have a dual sensor. Especially if you're looking at roofs and facades, typically a smaller drone tends to be easier to fly in the congested environments. So we've got questions around. Chris is asking whether can we use an Autel Evo 2 640 TV1. Yep, so I've already answered. Autel drones are also good drones to use. One thing I will say with Hammer missions, if you want to do the scaling and tuning workflows, that at the moment are only compliant with DJI, but you can still do all the other workflows with Autel in Hammer missions. I think we talked about so JP's got a question about what plan is the thermal service under Ascend Pro, Cruise, and Enterprise? The thermal is under cruise and enterprise. But yeah, very happy to talk about plans, kind of more one to one to understand what your needs are. Yeah, very happy to schedule a conversation on that. Norman Chan has a question. I might have missed this, but is there preference in the pallets we should use? So yeah, on the pallets, we would highly suggest using the iron bow pallets, and that's because it strikes a good balance between giving you the thermal contrast between different anomalies, but also not over exaggerating or under exaggerating them. Whereas rainbow over exaggerates certain things, and white hot can be a bit under exaggerating those things. So iron bow would be the best with respect to kind of as from a default point of view to start with. I've got one more question here, and we're just on the hour, so let's go for this. Is in a facade inspection, is it possible to insert different distances along the facade? Um, you can go for different distances along the facade, but the way you would have to do that is when you do the flight planning, you'd have to create a new section for every distance. So let's say if you had a facade with a different shape, you just kind of model that as a separate flight plan for every distance that you need to do. Probably running out of time today to showcase that, but the idea here is that you create many different small mini facade missions, each with its own distance, to be able to capture the facade correctly. Right. Okay. I think I whizzed through that, and there are 4 questions that have already been answered. So hopefully everyone's questions got answered. But if not, please feel free to send us an email at team@hammermissions.com. Very happy to kind of do a follow up to the session. And yeah, I'll hand over to Brandon now to kind of talk a little bit about where we go from here.
Perfect. Good job, Varun, getting right at the hour on the last question. I don't know how you orchestrated that, but thank you everyone for joining. We do have the link for the next upcoming seminar for next month. We'll share more details as we fine tune everything for it, in terms of topics, but it'll allow you to at least get an email and notification with all the details as they come in. And please register for the one next month.